All right, let's dive right in. We're about to take a pretty incredible journey deep inside the human brain. We're going to pull back the curtain on how we actually see the world, how our memories really work, and what's truly driving the choices we make every single day. So let's start by questioning the most basic thing we think we do right. Just seeing. I wanted to start with this quote because it just cuts right to the chase. We all assume that what we look at is what we see, right? That it's a one-to-one thing. But it turns out there's this massive gap between the light hitting our eyes and what our brain actually decides is important. Seeing is so much weirder than we think. And that brings us to our first big topic. You have to forget this idea that your eyes are like little video cameras, just passively recording everything. They're not at all. They're active interpreters, constantly making snap judgments about what matters and what's just background noise. See, it turns out we basically have two kinds of vision. There's your central vision, which is what you're using right now to see these words in sharp detail. But then there's your peripheral vision. And that's the real MVP. In one study, they flashed pictures of rooms at people for just a fraction of a second. When they blacked out the middle of the picture, people could still tell you, oh, that's a kitchen. But when they blacked out the edges, the periphery, people had no clue. Our brain gets the whole gist of a scene from the blurry stuff on the sides. Our brain also uses clues from the world to figure out how to interact with things. And there's a fantastic word for this, affordances. It sounds complex, but it's super simple. It just means that good design screams at you how to use it. A doorknob is shaped to be turned. A chair is shaped to be sat on. It gives you a cue without any instructions needed. And we've all felt the pain of a bad affordance. You know the door, the one with the big handle that just begs to be pulled, but you're actually supposed to push it. And you stand there for a second feeling kind of dumb. Well, guess what? It is not your fault. That's a design flaw. The design gave your brain the wrong signal. Okay, so let's take this idea and apply it to something we do constantly without even thinking about it, reading. You might think you know how it works, but just like seeing a room, the way we process words is full of surprises. So let me ask you this. We've all been told that reading text in all caps is super hard, right? It feels aggressive, it seems to slow us down. But is that really true? Is there something about those capital letters that just breaks our brain? Well, to get the answer, you gotta know how your eyes physically read. They don't just glide smoothly across the sentence. Nope. They make these super fast little jumps called saccades and then pause for a split second to absorb the info. Those are fixations. And here is the absolutely wild part. During the jump, the saccade, your eyes are effectively blind. Your brain just edits out the blurry mess and stitches it all together so you never even notice. So, back to the question. The reason we read all caps a little slower has nothing to do with the letters being harder to recognize. It's just practice. Almost everything we read is in lowercase, so our brain is a finely tuned machine for recognizing those shapes. If we lived in a world where everything was in all caps, we'd read it just as fast. So yeah, that whole idea, total myth. Okay, so we've established that what we see isn't a perfect picture of reality. Now let's get even more personal and talk about our memories. You might want to buckle up for this one, because our memories are nowhere near as reliable as we think they are. Let's do a quick thought experiment. If I gave you a list of totally random things to remember, say wallet, cloud, bicycle, coffee, microphone, how many could you hold in your head right now without writing them down? What do you think? 7, 10? The answer for pretty much everyone is 4. That's it. Just 4. Now, you might be thinking, no way, I can remember a phone number. And you're right, but that's because your brain cheats. You don't remember 10 separate digits. You remember 3 chunks of information, the area code, the next 3, and the last 4. We are constantly, automatically chunking info to get around this tiny little limitation. But it goes so much deeper than that. Your memory isn't a video file that you just play back perfectly. Every single time you remember something, your brain is rebuilding that memory from scratch. And that means the memory can change. It can be influenced by what happened later, by your mood, or by someone else's suggestion. A psychologist named Elizabeth Loftus showed this brilliantly. She had people watch a video of a car crash. Then she asked one group, how fast were the cars going when they hit each other? She asked the second group, how fast were the cars going when they smashed into each other? The result? The smash group estimated the speed as way higher. But get this, a week later, they were more than twice as likely to falsely remember seeing broken glass in the video, which wasn't even there. One single word literally rewrote their memory.
So, if our memories can be edited, what about the things that drive us forward, our motivations? Well, as you can probably guess, those are also being guided by some powerful hidden forces, in this case, brain chemistry.
Let's talk about dopamine. We always hear it called the pleasure chemical, but that's one of the biggest misconceptions out there. Dopamine is not about the feeling of pleasure itself. It's the chemical of anticipation. It's the thing that makes you want and seek and search. It's the engine of motivation, always pushing you to go find a potential reward. And this system creates these incredibly powerful, sometimes addictive little loops. It all starts with a cue, that little bing from your phone. That sound predicts a possible reward. Boom, dopamine is released. That gives you the urge to seek. You just have to check the phone. And then you get a reward, but it's a variable one. Sometimes it's a great text, sometimes it's junk mail. That unpredictability is the key. It reinforces the whole loop, making you even more likely to jump the next time you hear that ping. Okay, we've seen that our perception, our memory, and our motivation are all being heavily steered by these systems running under the hood. So that leads us to the biggest question of all. When it comes to the choices we make, how much of it is really conscious? I mean, think about it. Who or what is really calling the shots? You probably believe you logically weighed the pros and cons of your last big decision. But the science is pretty clear. The vast majority of our choices are made by our unconscious mind, using these ancient automatic shortcuts. We are so powerfully influenced by what other people are doing. That's social validation. We are terrified of missing out on something. That's scarcity. We make choices that reinforce how we see ourselves, and we feel this deep-seated need to repay favors. And under it all is this primal need to feel in control. These things guide us to a decision, and then our conscious brain just swoops in at the end to make up a logical-sounding reason for it. So let's put it all together. It's like we're walking around with a user interface, our conscious mind, that thinks it's in total control. But underneath, the real operating system is running on this ancient, powerful, hidden programming. Our brains don't record, they interpret. Our memories don't replay, they reconstruct. And our choices are often made long before we are even aware of them. Look, understanding all this, it's more than just cool trivia. It fundamentally changes how you see the world and yourself. It gives you the tools to communicate better, to build better things, and maybe, just maybe, to make slightly more conscious choices in your own life. So the real question is, now that you know a little more about how your mind works, what are you going to do with it?